But before I start, I want to show you the soul of Nvidia, the soul of our company, at the intersection of computer graphics, physics, and artificial intelligence, all intersecting inside a computer in Omniverse, in a virtual world simulation. One of the industries that benefited tremendously from scale, and you all know this one very well, large language models. Basically, after the transformer was invented, we were able to scale large language models at incredible rates, effectively doubling every 6 months. So what we need are bigger GPUs. We need much, much bigger GPUs. We recognized this early on, and we realized that the answer is to put a whole bunch of GPUs together. And of course, innovate a whole bunch of things along the way, like inventing tensor cores, advancing NVLink so that we could create essentially virtually giant GPUs, and connecting them all together with amazing networks from a company called Mellanox, InfiniBand, so that we could create these giant systems. And so, ladies and gentlemen, I would like to introduce you to a very, very big GPU. Blackwell. Ladies and gentlemen, enjoy this. We're going to have AI working with AI, training each other, just like student-teacher debaters. All of that is going to increase the size of our model. It's going to increase the amount of data that we have, and we're going to have to build even bigger GPUs. This is Blackwell sitting next to, this is the most advanced GPU in the world in production today. This is Hopper. This is Hopper. Hopper changed the world. This is Blackwell. When we were told that Blackwell's ambitions were beyond the limits of physics, the engineer said, so what? And so this is what happened. Overall, compared to Hopper, it is 2.5 times the FP8 performance for training per chip. It also has this new format called FP6, so that even though the computation speed is the same, the bandwidth that's amplified because of the memory, the amount of parameters you can store in the memory is now amplified. We would like to have a bigger GPU, even bigger than this one. And so we decided to scale it. And notice, but first, let me just tell you how we've scaled. Over the course of the last 8 years, we've increased computation by 1,000 times. 8 years, 1,000 times. Remember, back in the good old days of Moore's Law, it was 2x, well, 5x every, 10x every 5 years. That's easiest math. So this is what a DGX looks like. Now let's see what it looks like in operation. Okay, let's imagine, how do we put this to work, and what does that mean? Well, if you were to train a GPT model, 1.8 trillion parameter model, it took apparently about 3 to 5 months or so with 25,000 amperes. If we were to do it with Hopper, it would probably take something like 8,000 GPUs, and it would consume 15 megawatts. 8,000 GPUs and 15 megawatts. It would take 90 days, about 3 months. And that would allow you to train something that is, this groundbreaking AI model. And this is obviously not as expensive as anybody would think, but it's 8,000 GPUs. It's still a lot of money. And so 8,000 GPUs, 50 megawatts, if you were to use Blackwell to do this, it would only take 2,000 GPUs. 2,000 GPUs, same 90 days, but this is the amazing part. Only 4 megawatts of power. Google is gearing up for Blackwell. GCP already has A100s, H100s, T4s, L4s, a whole fleet of NVIDIA CUDA GPUs, and they recently announced the Gemma model that runs across all of it. Creating a digital twin to build a computer that was built in a digital twin. And so let me show you what Wistron is doing.
To meet the demand for NVIDIA accelerated computing, Wistron, one of our leading manufacturing partners, is building digital twins of NVIDIA DGX and HGX factories using custom software developed with Omniverse SDKs and APIs.
What else can we generate? What else can we learn? Well, one of the things that we would love to learn climate. We would love to learn extreme weather. We would love to learn how we can predict future weather at regional scales at sufficiently high resolution such that we can keep people out of harm's way before harm comes. And so we're creating Earth 2, a digital twin of the Earth for predicting weather. And we've made an extraordinary invention called CoreDiff, the ability to use generative AI to predict weather at extremely high resolution. Let's take a look.
As the Earth's climate changes, AI-powered weather forecasting is allowing us to more accurately predict and track severe storms, like Super Typhoon Chanthu, which caused widespread damage in Taiwan and the surrounding region in 2021. Current AI forecast models can accurately predict the track of storms, but they are limited to 25-kilometer resolution, which can miss important details. NVIDIA's CoreDiff is a revolutionary new generative AI model trained on high-resolution, radar-assimilated WRF weather forecasts and Era 5 reanalysis data.
NVIDIA Healthcare, something we started 15 years ago. We're super excited about this. This is an area where we're very, very proud. Whether it's medical imaging or gene sequencing or computational chemistry, it is very likely that NVIDIA is the computation behind it. And so we have a great idea. We're going to invent a new way for you to receive and operate software. This software comes basically in a digital box. We call it a container. And we call it the NVIDIA Inference Microservice, a NIM. And let me explain to you what it is. A NIM, it's a pre-trained model, so it's pretty clever. And it is packaged and optimized to run across NVIDIA's installed base. And you'll assemble a whole bunch of chatbots. And that's the way software is going to be built someday. How do we build software in the future? It is unlikely that you'll write it from scratch or write a whole bunch of Python code or anything like that. It is very likely that you assemble a team of AIs. There's probably going to be a super AI that you use that takes the mission that you give it and breaks it down into an execution plan. Okay, let's talk about the next wave of robotics, the next wave of AI, robotics, physical AI. So far, all of the AI that we've talked about is one computer. Data comes into one computer, lots of the world's, if you will, experience in digital text form. The AI imitates us by reading a lot of the language to predict the next words. It's imitating you by studying all of the patterns and all the other previous examples. Of course, it has to understand context and so on and so forth. And so we need a simulation engine that represents the world digitally for the robot, so that the robot has a gym to go learn how to be a robot. We call that virtual world Omniverse. And the computer that runs Omniverse is called OVX. And OVX, the computer itself, is hosted in the Azure cloud. Okay? And so basically we built these three things, these three systems. On top of it, we have algorithms for every single one. Now, I'm going to show you one super example of how AI and Omniverse are going to work together.
The future of heavy industries starts as a digital twin. The AI agents helping robots, workers, and infrastructure navigate unpredictable events in complex industrial spaces will be built and evaluated first in sophisticated digital twins.
Today, we're announcing that Omniverse Cloud streams to the Vision Pro. And it is very, very strange that you walk around virtual doors. The next generation of robotics will likely be a humanoid robotics. We now have the necessary technology, and as I was describing earlier, the necessary technology to imagine generalized human robotics. In a way, human robotics is likely easier, and the reason for that is because we have a lot more imitation training data that we can provide the robots because we are constructed in a very similar way.
This is where inspiration leads us. The next frontier. This is Nvidia Project Groot. A general-purpose foundation model for humanoid robot learning. The Groot model takes multimodal instructions and past interactions as input and produces the next action for the robot to execute. We developed Isaac Lab, a robot learning application to train Groot on Omniverse Isaac Sim.
About the same size. This is what we announced to you today. This is Blackwell. This is the platform. Amazing processors, NVLink switches, networking systems, and the system design is a miracle. This is Blackwell, and this to me is what a GPU looks like in my mind.